presenting. I see here. I'm also very excited to be here. So please write where you're calling from. I would really love to know that. Where's the location? And while you write that, I would love to invite Aaron to the stage. Hi, Aaron.
Hey, Stjepan. Thanks for having
Hey,
me on.
of course. Nice to meet you, and thank you for the patience and waiting for another couple of weeks for this.
Of course, of course.
Yeah. Aaron, please tell us a little bit about yourself. Who are
Sure.
you? What is Augmenta? Let's start with you first, and then we can talk about the company.
Yeah, sure. So I'm Aaron. I'm the co-founder and the chief product officer at Augmenta. Bit about my background. So I didn't actually come from construction. I came from industrial design. So I used to design Blackberries at BlackBerry, but I moved into software, moved into digital product design, research with really a focus on 0 to 1 products. And a bit about how I got into this domain is I met my co-founder at Autodesk. So at Autodesk, Francesco Iorio was the director of computational research there, and he invented and then spearheaded the generative design program there. So generative design at the time, this was around 2015 or so, was actually very much focused on advanced manufacturing, and that was, of course, much closer to my background as well. And I worked with him there to really develop the principles of how people would interact with these systems. So it was really sort of pre the current, breakthroughs in attention around ML. And it's really one of the first applications of using computers to design solutions for you, as opposed to, traditional CAD interface where you are drawing a solution that you've developed in your head. So there are a lot of new problems to solve. No one had really sort of thought about how to do this before. I worked with him to really develop the principles of how people should define a problem. What do I do if this thing's presenting tens or hundreds of results back to me? How do I make sense of that? How do I iterate on that, provide feedback to it? And, one thing led to another. We sort of always felt that there was so much more we could do with this approach. We thought AEC was really the right place to approach it. So eventually we decided to create Augmenta to solve that problem. That's what we've been doing now for a couple of years.
Okay, so tell me a little bit about that jump you guys made. So Francesco and yourself met at Autodesk, you said.
Yeah.
And who said it first? Who were like, hey, let's open a company. Like let's get out of here.
It was a very slow process, very organic process. I think that, we just sort of felt that, how much to say here? Autodesk is in a different position within AEC than they are in manufacturing, right? Within AEC, they have a sort of very much a dominant position, whereas in manufacturing, they don't. They're competing against very entrenched, large players. So you have a company like Dassault, who is far more sort of the standard in advanced manufacturing. So we're talking aerospace, automotive, and so on, than someone like Autodesk. So for Autodesk, I think that they were much more motivated to really try and push generative design as this potentially disruptive model in that space, but less so in construction. I think in construction, they're doing very well for themselves. As we see, there's not as much internal incentive to try and rock the boat too much. I think that is changing now to some extent. And of course, they have their own factors that they have to contend with. But what it meant for us ultimately was that, on the ground is us building this technology and being very excited about it, really believing that this could fundamentally change how people use computers to solve very complex, multi-variable problems, which is what construction is. We were just frustrated. We were increasingly frustrated that, we couldn't really get traction applying this idea to that domain. So the conversations happened actually over a course of a couple of years. So it sort of just, it was not sort of like a big flip, but it just sort of was this slow sort of realization that, okay, we were gonna have to do this on our own for real if we really wanted to see this through and really see it to the extent that we wanted to see it. We never wanted to be just another plugin, just another drop down or a button on a toolbar somewhere. We really thought, if you approach this problem from a first principles perspective, and treat the design of buildings like the design of integrated circuit or a chip, there's a real chance to introduce a new paradigm where you are in fact using computers to take in a bunch of requirements and literally just design an entire building single shot. Actually doing that is very, very hard. It's going to take a while to get to a point where we're doing that with entire buildings, but it is feasible, it is possible. And we built this company and started this company to really be the ones to try and make that a reality. So that's kind of the North Star that we've been working towards.
Okay, yeah, thank you for that background story. I'm so happy I asked. Yes, listen, we have people from all over the world. Hadi here is very excited. We have Tim. Hey, Tim, thank you for joining us always from Minneapolis, from Minnesota, -5 degrees Fahrenheit or 5 degrees Fahrenheit. And then we have Sergey from Mauritius with 25 Celsius. Yeah. Yes. So, where are you actually based? Where is?
I'm in Toronto.
In Toronto. Okay.
Yeah.
Awesome.
Yeah.
Yeah.
So we're founded in Toronto, but we're a global team. We're fully remote. So we've got a large team in the US, a bunch of folks here in Canada, a bunch of folks throughout Europe as well. So very much a distributed firm.
Yes. Listen, I know you had a presentation. Yeah, you can go ahead. Should I pull it up?
Yeah, sure. Let's do that.
Yeah. Okay. Awesome. Go ahead.
All right. So what I'm going to do here is kind of just walk everyone through sort of a high-level introduction. I know sort of the goal of these sessions is the demo, so we will focus on the demo. So I'll treat this more as a table of contents. So we'll kind of talk about what we'll show you, but we'll go through all that live, and you guys can hop in with any questions you have at any point. But where we are today as Augmentas, we are focused on electrical. As you kind of might, as I sort of suggested previously, our ambition is to automate the design of entire buildings. That is what we're working towards. But right now, we've started off with electrical. Number of reasons for that, but fundamentally our goal today is to help electrical contractors and electrical engineers dramatically accelerate their modeling and coordination process through the use of an AI-driven design system. So a bit about myself, we already touched on this, but I'm Aaron Szymanski. I'm the Chief Product Officer and one of the co-founders at Augmenta. What we do is we build these systems that automate the design of really the core engineered system. So we really care about the things that are behind the drywall that really drive the cost and coordination, or cost and complexity of construction projects. So your mechanical, electrical, plumbing systems, your structural systems. This is really the hard part of the building design process. So where we are today is we've got this product that automates the routing, modeling, and coordination of this conduit, or of electrical raceway, with a focus on conduit. And most of our users today are electrical contractors, primarily in the United States, and they're using us to get from 0 to 1 very, very quickly. So you've just kicked off a project, you've got your assets, you've got your Revit model, there's nothing in there, and you need to get to that first coordination meeting, which is next Friday, and you need to get that model populated very, very quickly. So that's really our sweet spot right now. So we'll take that model from 0 to something that is fully populated, it's coordinated. You can bring that into that coordination meeting with a lot of certainty around where everything's going to go, the quantity, the size I'm going to need for me to fit all that feeders in my branch and so on. And it's really about leapfrogging you from that start point to a fully modeled system very, very quickly. And it's really fundamentally, the value is that you can do that in way less time than it would take to do that manually. And that sort of unlocks other benefits as well that we can talk about. So I won't spend a whole lot of time on this because I'll just hop right into a demo. But again, just kind of think of this as sort of like a table of contents of the demo. Fundamentally, the way it works is that you define your problem. So you give it a Revit model, you give it your sources and destinations in that model. You can provide your preferences or the context you have around where you can or can't route in that model. You provide a description, a conduit run schedule that describes the runs that you want to, or the equipment that you want to connect to your to and froms in a given project. You can specify additional design rules like your elevations, your supporting methods, your clearances. And once you've set all that stuff up, you hit generate and you're kicking off a generation process. And because you won't really see what's happening behind the scenes in the demo, I do want to spend a little bit more time on this. But fundamentally, what is happening is that our system, which operates in the cloud, is extracting site geometry, the information that it needs about your site, and it's performing a spatial analysis on that site. And essentially what we're doing, or the way we explain, is that we're trying to look at your site the way a foreman would look at it, where our goal is to produce solutions that are not just sort of generically routed, but are actually constructible. So we perform a supportability analysis based on the types of supporting methods you specify. So that can be a floor stand, trapeze, wall standoff, and so on. It's going to look at the site, identify the spaces in that site that can be supported with those methods. So for example, it's going to prioritize areas with open slab above over, let's say, directly underneath a duct where there would be some obstacles to get that threaded rod around and get that thing supported. We're looking at the penetrability of walls. We have an understanding of the cost of penetrations based on, the type of the wall, the amount of conduit that's going to be running through that wall, and so on. So there's a number of different analyses that the system runs. And then within that understanding of the site, it generates a number of designs. And what it's doing is it really is single shot, full building, routing, and coordination. So by coordination, I mean it's producing clash-free designs in a single shot. And it's really solving a number of problems here. So it's obviously finding the optimal pathways for every single source and destination. So every run that you need to run in that project. It's figuring out optimal racking strategies. So it's going to figure out, how do I group these together to minimize the amount and the cost of the supports in a given project? How do I minimize the bends to reduce the difficulty of installation, to reduce my total degree of bend? It's figuring out the optimal layout within that rack. So how many tiers should it be? It will vary that based on external factors like the space that's available. And again, it's trying to reduce the cost of the supports that would be used on a given design. It's figuring out where to peel off and so on. So it really is solving a number of different levels of problems that BIM and VDC teams have to solve every single day. And that's ultimately what makes this so hard to do for those teams. Once you've done that, you can review the designs. You can review them in 3D, but you can also review the analysis of those designs. So you can learn something about the performance of these different designs. So for example, I can look at any one of these solutions. So here we've got a 3D view, we've got a plot chart, and I can look at what's the estimated cost of this, what's the estimated time to install, what's the amount of material, the degree of bend. And where this is really useful is that, in just a couple hours, I've just routed an entire hospital floor. So if I'm an electrical engineer, or I'm, say, working on a design build contract, or I'm sort of approaching a value engineering problem, well, now I can go and compare what would happen if I ran this with aluminum versus copper feeders. There's a size difference in those. There's a cost difference in those. I can just run both in parallel, and now I can get this very informed feedback on what is the optimal design for a given project. This is particularly useful for folks working at the earlier stages of the design process. Once you're happy with the design, you can push it back into Revit, where we've got additional tools for QA and QC to really help you make sense of that design, because you've really just gone from 0 to 1, right? So you started with an empty model. Now you've got hundreds of runs populated. We need to help you make sense of those designs so you know what you're looking at and can verify that everything's routed the way that you want to. But there's another reason we need this tooling, that is that our designs are not perfect, right? So it's just, we're very much in the early days of really applying ML to the design of, to the creation of designs in a complex 3D context. It's much easier to apply to 2D, if we're producing sort of high-level sketches or high-level routes over a floor plan. That's much more of a solved problem than it is in 3D. And so the result is that today, there are going to be things that you have to fix. There's going to be some soft collisions, extra bends, and so on. I'll show some of those in the demo just to kind of help you, characterize those and get a sense of, what that looks like in practice. But ultimately, the way we measure whether this is helping our customers or not is by comparing the time it takes for you to set up. So let's say, create that schedule, get the Revit model set up, the time it takes to generate, which, because it happens in the cloud, is sort of passive time. You can go work on other things while that's happening. And then the time for you to do that review, to make edits, whether because you're seeing issues in from a solution quality perspective, or you just simply want to approach that design in a different way because of something you've learned during coordination. So we sort of include all of that. And generally what we're seeing is that teams using this tool are cutting their time by about 60% or so. And that rate of time savings has increased in a very linear fashion over the last several years. So again, it's like any other ML tool. We're making significant advancements in the performance of the system over time. our solutions are getting better and better. There's less and less editing required. The setup gets faster and easier, and so on. So even what I'm going to show you today is really just a snapshot. If we were to give you this demo even a few months ago, it would be 50% reduction in time. Today it's around 65%, and that's continuing to increase. So we're really targeting to get folks to about a 75% reduction, so about 4x faster by the end of this year, and we're definitely on track to do that. So just some examples of what that looks like on some more complex projects. This is a hospital. I've sort of hidden all the background geometry, but this was against fully, detailed and coordinated mechanical and plumbing backgrounds. Same for a science lab, so very similar level of complexity, but on average, we're able to about cut that in half down to about a third. So what we're talking about today is electrical, but our goal is to do this not just for electrical, but for mechanical and plumbing as well. And it's not simply about just copying the workflow I'm going to demo over to those trades, but it's about being able to simultaneously coordinate those systems in a single shot. So imagine everyone setting their own requirements, their own schedules, their own preferences around where things route, and you hit a button and you're generating a fully coordinated MEP system in a single shot. Really what we're trying to do is we want to eliminate the coordination meeting. It's going to take us a little bit of time to get there. Obviously, it's a very complex problem to solve, but like I alluded to before, this is very much a solvable problem. And that's really why we built this company, because once we can start to do that, that's when we can really start to take weeks or months off of construction schedules. Whereas with electrical today, we're helping the electrical contractor a lot. There's certain types of projects where, a data center, electrical is the critical path. But for us to really bring this benefit to the whole industry, we need to at least be hitting these MEP systems simultaneously, and that's what we're working towards as well. Let's see. And then we got a question. Can you plan to penetrate steel beams along the neutral axis where the above ceiling space is limited? So you can, and what I can do is I'll touch on that in a little bit in the demo. So by default, the system will not penetrate steel beams unless you give it explicit permission to do so. So we sort of have, I'll just show you, but we've got different routing boxes where you can indicate areas where penetrations are possible, and that gives the system the option to penetrate through there. So that's really how you would do it in those cases. But by default, we are always going to avoid any solid geometry in that site. The exception would be walls and floors and things like that, where you can set more general rules allowing for penetration. But anything a little bit more, anything in the structural categories or the mechanical and plumbing categories, it really is up to you to make that explicit indication of where you can and can't penetrate. All right. So that's sort of a high-level overview. Yeah, would love to hear any more questions. Otherwise, we can hop into a demo.
Yeah, this was awesome. Thank you for presenting it so well. So yeah, now it makes sense how you got started with electrical. I was about to ask you, because you showed some projects that probably you're gonna is it? I was about to ask you, is it only residential that you're covering? But you showed healthcare, you showed data centers. Is there any limits to what this can do? Is there any building shape that this Augmenta can work with?
We are not currently limited to any building typology. We perform best actually on more complex projects. So we've run multiple data centers, multiple hospitals. We actually have not run, I don't think, any residential projects. I think we actually have one going on now that's a condo building. But we find really the biggest application of this is in those more complex projects, because those are the ones that need it, right? If you really have hundreds of runs that need to be woven through these very tight spaces. Basically what we find is that the more complex, there's sort of in that initial setup period of setting up ACP, there's like a linear increase in setup time, but a far more aggressive rate of time savings. So that means on a very small, simple project, we've seen this, like a clinic, it's a 10-room clinic. To me, that's a threshold of, given the time it would take for you to set this up, you might just want to model that yourself. We might save you some time, but you're not going to get that enormous time savings. Whereas on a data center or a hospital where you are routing, this is weeks of manual modeling and coordination. That's where you see those really significant time savings. So I would say that our most common project types are data centers. We've got multiple running right now. Hospitals, we've seen a lot of hospitals. That seems to have quieted down a little bit in the last sort of quarter, being taken over by data centers. We've had several manufacturing facilities. I would say, so we do manufacturing facilities well. One thing that we don't support quite so well yet is heavy industrial facilities. And the reason for that is you tend to see a lot of very specific support methods. You know, folks are often building custom support to route through those sites, and we're not as good as interpreting sort of the geometry in those sites quite yet. Whereas something like a manufacturing facility we can handle. So I'm talking about like a oil refinery versus a manufacturing facility. We can do the manufacturing facility. Oil refinery would be a little bit more challenging for us. We've done a number of commercial projects, but as we all know, commercial is not, there just hasn't been as many commercial projects recently. So it really is quite diverse. We have a question about the routing underground. So we do route underground in a limited fashion right now. It's very much in an alpha stage. So we route underground, but grid aligned, as in you can route, but it's going to be 90s, kind of like a snake, right? What we don't currently support is point-to-point routing, sort of as crow flies, which is what you get quite often in these underground projects. So that's sort of where we're at. It's something that we are working on this year, is sort of true underground routing. So keep an eye out for that. If that's something you're interested, we'd love to talk about that. Working with existing conditions. So not yet. We don't currently work with point clouds particularly well. The challenge with point clouds is that a human being can look at a point cloud and they know what's what. It's actually hard for our system to extract meaning out of that type of geometry. So that's something that we're working on, and I can't say we officially support quite yet, unfortunately. So generally, this is something that's going to work better on greenfield projects for that reason. Can we design modular hospitals? Well, yes, I think that there's nothing particularly unique about from our software's perspective. I suppose it depends on what you mean by modular. We've had customers using us on modular projects where you're putting the building together with these different components, but the feeders that are feeding those different sections are still being routed almost like on a per project basis. So that's one application that we've seen. The other is within those modular components, I'm trying to design modular electrical rooms and so on. We actually have a customer using us to do that as well. So you'll run our system to produce that design, and of course you're then replicating that design afterwards. And then the last question for how much it costs is hard for me to answer here because it really depends on the size of your team and how much volume you run through. So we charge on our licensing is company wide. So we have unlimited users, unlimited projects. We don't really sort of, there's no limitations there. If you kind of think about it, our biggest cost is when you hit generate. The compute is extremely expensive. So what we do is we take in an estimate of what's the approximate volume that you're going to be running through the system. And then the pricing is based off of that. So that's something that would just need a follow-on conversation if you want to get more detailed pricing. Modular plug and play connectors and different cable management levels. So the one thing just around that is that we don't currently support tray, which is sort of an important limitation to call out. So it really is right now on just the conduit side. So where people are generally using us is in the US, many projects are run with conduit, most still are. So people are running feeders, they're running branch. With our system, tray is something that we're working on. And how do you feed it? Input, I'll show you that in the demo. But yes, it is conduit run schedules.
Okay, awesome. Aaron, thank you, man. Like you're doing my job for me.
I didn't need to be
here. That's awesome, man.
Sorry, you know what? I will let you ask the questions.
No. Please. Hey, go ahead, man. It's your show. Listen, I'm just here as a messenger anyway. So I'm not here there, so don't worry about it. It's just that I'm just joking, So, anyways, please go ahead with the demo. You see that please, everybody in the audience, ask your questions. You see, Aaron is amazing at covering them and answering them. And if anything sparks your curiosity, please just ask, and we're gonna cover it afterwards. Aaron, go ahead. Stage is yours.
All right, great. So there is great demand for. Yes, we do have plans to move into the European market with greater support for cable tray. So let's kick off. What we're looking at here is Revit. We all know that. And what I'm going to show you is how you would use ACP to produce what we have on the screen here. So this is a large sort of commercial warehouse type, let's say, yeah, commercial, so warehouse / office type building. So this is a real project. I won't sort of zoom in too much on the building details, but I will zoom in on the conduit details. So everything we're seeing here, think about how long it would take you and your team to model and coordinate this manually. I won't sort of feed you with an answer, but when we ask different customers this, they'll say something in the order of, let's say, 1 to 2 weeks. And this is something that was entirely generated single shot within ACP in about 40 minutes. So there was some setup time to go build out the schedule, but the actual generation process was extremely fast. And the output is something that we bring into Revit, and we can zoom in here. You can see that we're connecting to all the equipment. We're laying out those racks. We're coordinating around different obstacles. I'll spend more time looking at the solutions in a little bit, and we'll look at it in ACP. But I just kind of want to start at the end here to show you what type of output is possible. And honestly, by our standards, this is a very simple project. So something that you can generate in 30 to 40 minutes is, at this point, fairly easy for us to handle. We're running data centers that can take up to 12 hours to generate. So you're running them overnight with, we've run 18 miles of conduit in a single shot overnight in a single generation. So we ran all the feeders and almost all branch for our entire data center in a single shot. So we've managed, especially over the last year, to make a lot of progress in terms of the scale of site that we can handle. But so how do we get here? Well, let's start off with the setup that happens inside Revit. Okay. So what I'll do is I'm going to hop over to the ACP import view. So basically, we've got a special view inside inside Revit that controls what ACP sees. So by default, ACP, that's the Augmented Construction Platform, is going to route around, like I mentioned before, solid geometry. Of course, it has special handling for things like walls and certain elements, but generally speaking, it's going to coordinate around anything you want it to coordinate around, and you control that by controlling the visibility of those categories or elements in this view. So I've got my building open. I've maybe filtered out the things I wanted to care or don't want it to care about, but really the most important starting point is that I've got my equipment. So Augmenta does not place equipment for you. This is something that you've placed. It's either coming from the engineer model or it's something that you've placed yourself. And every piece of equipment here, if I open up, let's say, a panel or so, it's got some kind of a unique identifier. Where is that? Panel name, DH2A, right? So not saying anything particularly revolutionary here. Every piece of equipment, so that's my sources, my destinations, is going to have some kind of a unique name. And I'll show you how we're going to use that in a little bit. So very first thing we have to do is we have to, on this project, define our to and froms. So I have gone and I've placed all my equipment. I've placed my junction boxes, my home run boxes. So all the sources and destinations have been placed. I'm going to launch ACP. I actually had it running back here. Okay. And I'm going to go, and while we're here, we're looking at ACP. So ACP itself runs in a web view that's embedded inside Revit. So we have this plugin here, and really the goal of this plugin is to read data out of Revit and then later to push a solution back in. We've got some tools here that I'll talk about in a little bit that really help you mark up this model, help you provide some of those preferences, and you can kind of see hints of those colored boxes back here. That's me providing information around where I can, can't, or would prefer that you route. We've got other tools for doing our QA, QC after that I'll talk about. But really the brains of the system is running in the cloud, and it's accessed through this web app. So right now I'm inside this is our demo environment, but this would be your company's personal environment. We're inside our projects, and we're looking at this demo project here. And what we see here is a list of studies. So studies are really the key organizing concept inside ACP. And a study is basically a what-if scenario. It's basically saying, with this particular setup of the site, if I were to use this conduit schedule, this site, and hit generate, what type of solutions am I going to get out of that? So earlier when I talked about doing, for example, copper versus aluminum feeders, or as changes are happening to that project, I can create these new studies, I can generate against them, I can run multiple studies in parallel, and then I can go and actually compare them with each other. I can compare the stats, but I can also overlay them over each other so I can see what is the routing or the space impact of one sort of design decision over another. So if I create a new study, I just hit create new study. I have sort of a blank one here. And opening this up, the first thing we see is the conduit schedule and feeder schedule. So that's going to answer, Sanjay, your question. This is really one of our primary inputs here. And what's cool is that I can build out this conduit schedule, which for those maybe less familiar, the conduit schedule simply is, actually I'll create one and then we can talk about what's in it. So a conduit schedule defines the runs, the conduit runs I want to run between a given source and destination. So each one has a source, and I can go in here, and it's actually live linked to Revit. So it's pulling in all of the names that it can find in Revit. So I'll just pick one. I'll pick one just randomly here. It's got a destination. I'll pick another one randomly. It's got a system, and systems for us are something that we can later use to target design rules to. And then it's got a feeder ID. And a feeder ID is basically just a reference to a separate schedule, which right now is empty. I'll load one in. That defines the number and the quantity and the size of the parallel run. So I'm basically saying from ATS2 to CL1B, that belongs to a power system, and I want to run, two 2-inch conduits between that. So if I went to the feeder schedule, I can go and build out a new row. I just got to give it an ID. I can say, one parallel run, and I can pick a size, and then I can go and reference that here, right? And now I've got this run. Let's see. All right. So the other thing is, like you just saw, that when I load these in, or when I load these names in, these are actually live linked to Revit, right? So this ATS number 2, if I click the link button, I can go and actually find that element in Revit. And the reason this is important is that if I change data in Revit, if I change the name of a panel in Revit, that conduit schedule is going to automatically detect that change. It's going to flag that, hey, something has changed here. It's going to suggest that there's something with a similar name. So if I went here and let's say I just did ATS2, it's going to go and say, hey, there's, we couldn't find an ATS2. There's something very close though. Let's go look at what that is. ATS number 2, right? That's what I meant for that to be. I'm going to go ahead and change that here. So this is basically a real-time verification system that makes sure that my schedule is always completely accurate against the model that I have. And this is really important. This is here, if I've got 40 runs, maybe that's something I can manage myself and keep in my head. But again, these complex projects can have hundreds of runs. We all know that things are changing in the backgrounds. And also people make mistakes. They make these little changes. Maybe I wrote ATS2 in my Excel-based conduit schedule, but it's ATS, #2 in the model, and that's a link that's now broken, right? There's now a mismatch between that data. So we've put a lot of work into building this experience where we have this sort of real-time two-way link between the schedule and the model. But let's go ahead and clear this out and put in some real data so we can go ahead with the rest of the demo. All right. So the other way we can build out these schedules is most of the time, you probably have a schedule to start with. Maybe you built it out during estimation. Maybe your planning team has built it out. So we support the import of CSV or Excel formats. So I've got, for example, a schedule here. Let me pull that up. That maybe I pre-built here. It's got a different format than the ACP one, but that's totally fine because we've got this tool here to map those together. So if I'll go here and I'll load that in. And basically, I just need to map up. So source, that's my from, destination, that's my 2 column, system is my system column, feeder, perfect match. We have this guidance column that I'll talk about in a second, but I don't really have an equivalent guidance column in my feeder schedule or my conduit schedule that I built in Excel. So I'm going to skip that, and I can just go ahead and import that schedule. So first thing you see is that there's a bunch of errors found here, and that's because we haven't loaded in a feeder schedule. So let's just get that loaded in as well. And a lot of the time we see that folks who are using other systems. So they're using they've got an estimation or they've got a PLD workflow that's creating these schedules. Maybe they're exporting them out of Bluebeam. Maybe they're creating them in Evolve. So we really don't care where that schedule comes from. We've sort of designed this workflow to work with your process, the data that you already have. We really try to impose as few process changes as possible. And what this allows you to do, of course, is to work with that, right? So we've got this mapping workflow that really should take in any schedule format that you might have. So we've loaded in the schedule, and we see an example of what I was talking about before, where we've got this mismatch. So here, someone typed in that Excel C-1, but in Revit, it's actually called C1. We can go and verify that. We can change it. But we might actually say, no, we want the schedule to be the source of truth. There is supposed to be a C-1 that's, let's say, different than C1. So the other thing that we can do is place it in Revit. And what this is going to do is it's going to open up this other tool where I can actually go and place devices off of my schedule. So I think where this is really cool is, again, a workflow where you've got a planning process, your PLD team, this is a little bit more contractor specific. They've planned out their home run boxes. You've got those in a schedule. They're not in the model. I can go and systematically get all that content placed and make sure, again, that I've got a perfect matchup with that model. But for now, we'll just change it here. We'll do that with this one too. Okay, so we've got our schedule all set up here. Next thing we need to do, and let me just answer a couple of these questions that have come up. So Tim, you've got me a couple here. We'll understand maximum cable length for Cat6. No, not right now. So we don't sort of impose any hard limits based on cable length. What we're trying to do is we run a global optimization process that is trying to reduce overall length. We are building some tooling, some analysis tooling that's going to help you identify maybe where you might hit those limits. But really sort of the way to think about this is that the system is kind of working more towards goals. It doesn't sort of have hard limits around something like angle or length. It's really just trying to always minimize those as much as it can. Does it have a level of development that will reduce the model size? I'm going to assume you mean on the export side. So there's sort of the level of development on the import side, as in what LOD is this background model. HP doesn't really care. It just needs the basic geometry. It needs to know where the walls and the floor is. That's actually technically all that you need. And you just need equipment in there. On the export side, today we export our designs just using generic Revit system conduit. I'll show you an example of what that looks like. So we're not currently placing couplings and supports and things like that. So that's going to be probably the lowest level of development that you'd really be interested in working at. And then from there, we're really trying to make our output as agnostic as possible so that folks can use their existing modeling tools. So you are using Evolve. We make it very easy to flip over to a tool like that so that you can go and detail it yourself. And then would the contractor use the model to do coordination drawings where changes happen during construction? So that's a really good question. And I would say that it kind of depends on how big that change is. So a lot of our contractor customers, they're using this to do that initial population, right? And particularly, we know this is sort of unique to electrical. They're kind of having to catch up the most compared to the mechanical and plumbing trades who generally have more to start with. So the electrical contractor, they're getting started. They're often starting with nothing modeled. And they need to get this populated very, very quickly. And I would say that most of the value for them is that. It's getting that initial model populated. From that point on, as the subsequent coordination process occurs, there are going to be changes. If those changes are localized, like I just need to shift something from the left side to the right side of the hallway, we would suggest that you just do that manually. Right now, it really is more of a whole building design tool rather than sort of like a localized, editor, if that makes sense. But we have had projects where there were big coordination changes. Like turns out we can't run down the south side of this at all. We actually have to reroute entirely to the north, where it's effectively a redo. And for that, it's perfect, right? Because again, you can go and take something that would have taken weeks to do, and now I can go and flip, to this radically different set of pathways very, very quickly. So yeah, I guess to answer your question, it really depends on the severity. But really the big way to think of this is it's a global optimization process. It is a little bit more sort of whole building one shot. So you sort of want to be using it where it makes sense to do so. But yeah, very good questions. All right, so we've got our schedule built out. So now ACP knows what connects to what and what it needs to run between them. The next thing I want to do is give it a little bit more context around where I can or can't route in a project. Using the Evolve, Ariel, I'll answer that question in a second. But we don't have that issue, is the short answer. So the way I do this is, okay, I've got this project. There's things that I know about it that I need to tell ACPs, right? So ACP generally works with a fair bit of design freedom. I could sort of take what I've shown you so far, equipment, conduit schedule, and just hit go. And it's going to go and route that entire building already with no additional guidance. But quite often I have some idea in mind of where I want things to go. And we can specify that with these guidance tools. We've got two types, but they kind of work the same. We've got guidance boxes. The first is a preferred routing box, where this is basically a way for me to specify my preference, right? So it looks like it's effectively, I'm sketching out a magnet that draws the routes to that pathway. I'm sketching out may route boxes. Those are those ways I would indicate those penetrations. So again, I want to indicate where I can penetrate through the beam. I can indicate where I penetrate through the keep out boxes and so on. And, or sorry, with the keep out boxes, is sort of the inverse of that, right? So a keep out is a way for me to specify where I don't want you to go. So keep out is a way for me to say, look, in this room, this mechanical room, you cannot run any racks through here, but you're still allowed to hit equipment inside that space. And a guidance space is basically the same behaviors, except I can apply them to spaces instead of drawing these boxes manually. But that's really what we see here, right? So we've got keep outs. Maybe we blocked out some shafts or some areas that we don't want any racks running through. We have different routing boxes. So we've got a combination of may route and force route boxes, which are those preferred routing boxes. And this is a way for me to kind of provide this high level guidance to the system. Related to that is, if I want to get really precise, I can actually go and I can assign some of these runs to those preferred routing boxes. And what this will do is it'll force that run to pass through that box. So I can set up these boxes essentially as waypoints for those runs to pass through. Okay. So now I've gone and specified my to and froms, where I want things to go, where I don't want things to go. And really at this point, the next step is just to get that data up into ACP. So I won't sort of show this live just because it takes a couple of minutes, but this is really kind of the only syncing that happens, to answer Hari's question, where I would need to upload the geometry from that site over to Augmenta. This process generally takes a couple minutes, but it is one shot. Once you actually hit that generate button and you start generating the solutions, it is running in the background, it's running in the cloud, so it's not affecting Revit whatsoever. So generally, this is something where you'll set it up in the morning, you hit generate, it's going to run in the cloud. We're not touching Revit at that point. You can go and continue working after that. At the end, you're just pushing a solution back into Revit. That export process takes a couple minutes, but there's no sort of background syncing that happens. There is that sort of syncing or live connection that happens in the conduit schedule, but it's extremely light. We've put a lot of work into optimize it, so we've never seen or heard about our customers having any kind of performance issues as a result of that running. And again, it's only running when you have that view open as well. So we don't sort of have that problem where we're not sort of live updating data in your model as you're working through it. So in this tab here, I've uploaded the electrical model and the background geometry. And then the last pane here is my design rules. So here, I won't kind of go through all of them. I'll touch on maybe some higher level than others. The first is supports. Again, I won't sort of dive into this in too much detail, but essentially what we're doing is, even though we're not yet placing the supports themselves, we are very much considering the types of supporting methods that you specify when we're generating these routes. So in a separate part of the application, I can go and I can set up my support specifications. So it's literally just a prioritized list of, trapeze, floor stand, wall standoff, and so on. Again, I can scope that down to different parts of the site. So I can say, I've got, let's say, a manufacturing facility. In this area is the floor stands are acceptable here. Everywhere else is just overhead trapeze in all the office areas. We have different clearances from different elements. So we can specify clearances from walls, railings, and things like that. We have our conduit spacing. So this is edge to edge spacing, horizontally and vertically. And then we have our elevations. This is really probably one of the most important types of rules that you're going to set. So we have a lower clearance. So basically, what's the minimum height that this can run at? What's the maximum height that this can run at? That's my upper clearance. And then within that range, which might still be fairly big, what's my preferred height, right? So we sort of can set this preferred elevation in that sort of allowable range. ACP can still enter and exit this range, of course, to go and actually connect to equipment. But generally, I want to run above the ceiling. This is the allowable range above the ceiling, and I want to try and stay below duct. So this is my preferred height, is below where the duct gets run, right? So then within that, we are basically working on a very similar concept to that preferred routing box. It's basically a magnet. So the system will try to run at that height. It can still deviate where it needs to, but I've got, say I've got a clean shot at here 11 feet above finished floor. There's something in the way. I can offset down around it and then get back up to that elevation. Other than that, we've got some general rules around routing through walls. So this just gives us permission to route through walls. We identify which walls are interior and exterior so that we're not punching in and exiting the outside of the building. And then same for routing through ceilings. Generally, you want to leave this on because you want to be able to sort of drop down and hit equipment if it happens to be placed below a ceiling. All right. So at this point, and I will pause to answer questions in just a second. Basically, this is the setup, right? So this is everything that I need to do to define a problem for this system to go and solve. At this point, I would just hit validate, generate, and it will kick off that generation process. As it does so, then again, like I mentioned before, it's just running in the cloud. It's not affecting my Revit instance, and I'm free to, work on other things. All right. So let's see, questions from, okay, so Hari, I think I touched on your question. Marie, looks super useful regardless of how it works, but seems more like a mathematical optimization than AI. If not, what is the AI part? So it's a really good question. And underneath the hood, we're using a combination of more, let's say, traditional mathematical optimization and true sort of data-driven machine learning. The reason that this is not, so this is not a entirely, let's say, data-driven machine learning system. The reason for that is that particularly within the 3D context, we are not able today with present day technologies to arrive at the level of accuracy that is sufficient, particularly for contractor applications, where they need something that they can bring into actual coordination meetings and get actual design sign off on. So we knew that going in. So our system is a hybrid. I won't quite go into the details of where we sort of use different things, but essentially we've got a solution generation pipeline. Some parts of that solution generation pipeline are driven by machine learning. And you can sort of think of this as a sort of like a higher order coordinator, let's say, that identifies sort of the high level strategy for routing, whereas the actual details of how that route is executed is done using more sort of traditional mathematical optimization and computational geometry approaches so that we can get to the consistency and accuracy that we need to for this application. Okay, and then Tim, like areas below rainwater leaders for the roof drainage. Tim, I think I might need a bit more context on that question. And then where do we upload the model data to? So depending on sort of how you mean that question, what we do is we extract a limited subset of the site geometry. This is what we need to be able to run our system against. So we are not uploading the entire BIM model or the Revit model or anything like that. The data itself is hosted on AWS entirely on US servers. let me know if that is not what you meant with that question.
Can I just jump in with my question as well?
Yeah.
So, I mean, many of these questions are very technical. What I'm mostly looking at like the process of this, because like in the beginning, you showed a presentation where you said, okay, it was hard to kind of estimate because like you said so many hours, like 150 modeling hours, but like it gets down to like, I don't know, like 60%. But I don't know like how big the project is, or is that a typical project and so on. So that I missed a bit of context. But I'm wondering like, because the most time was actually spent, okay, preparing is one thing. I understand that. You need to put the boxes, everything you explained right now. The generation is another thing that takes up a bit of time. I also understand that. But then the QA QC part, is there like a typical checklist that you would recommend people? Like, what should I be like careful about? What should I watch for? What should I check? Because at first glance, when you look at the 3D, it's like, oh, okay, it looks very nice. It looks amazing. But what should I really pay attention to?
Yeah, that's a good question. So let me keep that in mind once I go back to the solution itself, and we can talk through that.
Sure.
And we can talk through sort of what we're doing about that as well from a product perspective. So, okay, going back to the studies, I'm going to go back to my list of studies. So let's imagine I hit generate, I hit validate. When I do that, that button turns into generate. I hit generate. Let me load up a previous solution. So this one ran in 26 minutes, and we let me just jump right to the solutions. It's basically on the same setup. So these are a number of solutions that were generated against that site input that we just went through. This is that plot chart I talked about before, right? So we can load in and view those solutions in plot chart form, where we can compare estimated costs and construction time, or any other sort of quantitative factors or evaluations of a given design. And then otherwise, let me just open up one of these guys. I'll just go number one. It's going to load it into this viewer. Let me just make this bigger so that you guys can see what we're looking at. Okay, so here we've got a 3D view of the building, and I'll just hide the building so we can see the solution for a second. So this is the solution that was generated. So you can see here it's avoiding the keep out areas. It's drawn to those preferred pathways that we specified, and kind of zooming in, just sort of touching again on the problems that it's solving. So we think of this as overall routing problems. So finding the most efficient pathways from source to destination in a way that minimizes total degree of bend and total material cost. So which is primarily driven by the length, but it's also driven by, for example, the size and quantity. So it's more expensive to run a lot of, or sorry, to have a lot of large conduit and introduce a lot of bends in large conduit than the smaller conduit. We are hitting in to the top of the equipment. We can drop out to the bottom of equipment as well. But that's sort of the high level overview of the solution. Okay, so what we can do now, though, is start to talk about some of the details at a quality level. So, and there's a number of things that we're working on here. So from a QA, QC perspective, let me see here. You'll see things like this, where this sort of bend just doesn't make sense, right? Like it really should have gone out the front and merged into the rack there. Let's see what else. There's going to be areas where it'll still sort of produce these slightly less than optimal sort of decisions around, for example, how it's ordering on the panels. So we generally find that there are a lot of these, like, it's still sort of these localized things that you need to look at. It really is probably the way to think about it is that you're looking at it as if you had a junior modeler prepare this model for you, and you now need to go ahead and review it. And really, a lot of these things are what we're focused on improving, and where that it's sort of the primary factor that has led to that rate of time savings improvement, or that productivity improvement, has just been a very concerted and sort of systematic effort on the part of our engineering team to reduce these issues. Here we see cases where, for some reason, ACP could not figure out how to place that bend, right? So we call these an unknown part. Like, we know that there's a connection here. This doesn't look particularly complicated probably for a human being to solve, but there's just something about it where some constraint could be met, and we couldn't quite figure out how to place that part. The last thing that you'll kind of see is maybe I can find some here. Sometimes we get some self collisions as well, generally within racks. Let me see if I can find any. Maybe there's something here. Sort of funny to be going through a demo trying to find what's wrong, but I do want, we're very open about where the system is. Well, you'll have to trust me. Sometimes we do get self-collisions that you'll have to fix. So what we've done, though, to help people do that is, at this point, we've got this analysis tool. When you're happy with the solution, actually, before I jump into that, I just want to touch very quickly on being able to compare, because I think this is where it gets useful from a value engineering perspective. So I can load in other studies. Let me make this a bit more visible, or solutions from other studies, and I can compare them against each other, right? So here we've got some very different pathways being selected. So even within a generation, the system is exploring different ways of solving that problem. So it is going to explore, different, it's going to find different ways of sort of optimizing for those different goals. So sometimes you'll have solutions that have less install time, but greater length because of the materials sort of involved and so on. And where that's particularly useful is, okay, I've got a big coordination change. Let me evaluate the impact of that coordination change. What does that mean from a routing perspective, but also from a cost and time perspective? I'm at the engineering stage. I want to evaluate the impact of a potential design decision that I'm making. Where should that electrical room go? Where should the riser go? Those big sort of design decisions that today generally are made through intuition and expertise. Now you can prove it to yourself with a lot more confidence just by running those different setups in parallel and then going in and comparing them against each other. So I can compare visually. I can also compare the statistics of those different solutions to really understand the impact of one over the other. We think that's really quite powerful. So once I've, let's say, landed on that solution, I would go export to Revit, a system conduit. That will take a couple minutes, but the output will basically just look like what we saw here, right? So this is an outputted design out of ACP. So what we're doing here is we output in just a very generic, we use system conduit for the straight sticks, and we use a very, very generic conduit fitting for all the bends. We have built a tool that allows you to convert all those parts to whatever you want. So if you are using Evolve, you're using BendWorks, you're using SysQ, you can just open this up and it will convert all of our parts to whatever part you want, and we just map, or you help it map the parameters that you want to map. And generally we can convert an entire site. Again, we've run entire data center sites in a couple minutes and got all those parts converted. So it's really, really fast process. And we've done that intentionally because we want to be very agnostic with the designs that we output. We know people use different systems. We are just trying to get that conduit populated for you. We're trying to get all that data into that conduit in a way that's useful for you. And then it's really up to you to use whatever workflow you want to go and do that final sort of assessment. But to aid with that assessment, we have built some tooling to help folks do that QA/QC. So if I put myself in the shoes of someone using the system, I've just gone from 0 to 1. I need to make sure that, we would identify for you if something wasn't routed, so you know that everything that was in that schedule is being routed, but I still want to verify that, right? So we've built tooling here that allows you to visually analyze the output based on different parameters or different factors, right? So here I can color those sources and destinations by the source. So all the conduits leaving this panel are going to be this color and so on. And that really allows me to trace down those designs to make sure that everything is routing where I need it to. This is extremely useful in practice. We can sort by destination. We can sort by, for example, system. I don't know how many systems are in this project. Okay, we've got a bunch of systems, so we can sort by system. And just in practice, the way this works is that folks will review the solution. They'll spend some time reviewing the solution, walking through each, generally folks have a favorite of what they're going to filter by. So that could be, for example, by source. It could be by run ID. Those are kind of the most common. We make it easy for people to isolate these. So they can go and isolate, and that's only going to show, there it is, the run that belongs to, for example, that source. Undo that. And even from an editing process. So this site is a little bit cleaner, but let's say I did have some of those. Okay, so maybe there are things here. Okay, here we go. Here's the self-collision. Oh no, it's not a self-collision. Well, here's an issue that we saw before where we've got the bend sort of wrapping sort of the long way around. So something I can do, is really I can just focus down, just isolate the conduits that belong to this panel. That's L2P2B -1.1. Isolate by that, make those edits, unhide that, and go and look again at sort of each individual rack. So in cases where people are doing that review, people have different methods. So you can do it by source. A lot of folks will go by destination, and they're just checking, am I happy with the layout of these racks? Am I happy with, are in fact my parallel runs being run parallel with each other? So I think a lot of this is simply that even if we were producing perfect designs, there's always going to be some amount of time dedicated to that QA QC process, simply because you are going from 0 to 1. And that's going to increase linearly as the complexity of that project increases, because again, I've maybe gone from nothing to 400 runs all in one shot. I'm seeing all of them for the first time. So I know, we can guarantee that someone is going to want to work through each of those, verify that they're happy with it before it's something that they're comfortable bringing into coordination. All right. So with that, let me go through a couple more questions. All right, Tim.
Mm-hmm.
Can Augmenta recognize areas needed to keep electrical equipment and panels away from areas where plumbing passes above? The equipment itself. So we don't help with that. We don't currently help with anything around equipment placement. We really just handle the raceway itself. So ACP will avoid those systems, but we're not sort of flagging for a user right now that, hey, you've put a panel under here, or the plumbing needs to move because it's running over there. And that in some ways sort of related to your next question. Does it work with codes like the NEC and plumbing codes? So we did originally design the system with NEC in mind, right? We're not demoing plumbing right now. So as we build up plumbing, it will be considering the plumbing codes and mechanical codes in general. From our perspective, because right now we're solving primarily for routing and not so much for the actual engineering decisions. We're not doing wire sizing. We're not quite doing grouping yet, though we are working on that. We are working on some of these factors, but right now, in terms of what's commercially available, it really is primarily focused on the routing and the coordination process. So we do have considerations, code-based considerations, for example, around supportability, but really the biggest controls are going to be those clearances that I mentioned. And those tend to be very project specific. So we're really relying on the customer to know what's right and what the requirements are for their particular project. Sanjay, do we use complex bends like kick 90s or rolling offsets to reduce degree of turns? We do. We do actually use some very complex bends. So we handle kick 90s. We do occasionally use rolling offsets, though we try to avoid them. I can see if I can find any here. Let me see here. If I could have loaded up a more complex project for you guys, like a data center, which I unfortunately can't do for confidentiality reasons, and I think we'd see more of those complex bends. But of course, it's going to try and use simple bends. It's going to try and use standard angles wherever it can. But let me see here. In short, we do handle those, and we sort of have a hierarchy where we try and handle it with the simplest solution possible, but in cases where that's not sufficient, we will resort to more complex bends and kicks and offsets. And then Marie, would you be able to use it completely on your own, or is it safer to use Augmenta with support from you? So we don't really have an option right now to use it on your own in the sense of sourcing it locally, if that's what you meant from a technical perspective. But if you mean as an end user perspective, this is built for you to use, right? So we're not a BIM consultancy. We are a software builder. All of our customers are driving it themselves. We do have an awesome support team. I promise not to be salesy in this in this session, so I won't spend too much time on that. But we have an awesome support team, all XBIM managers and modelers themselves. We get very hands-on with our customers when they need to, so you'll be very well supported there. And that's generally our model right now. So we don't, from a technical perspective, there's no current model for on-prem hosting. So it's all going to be cloud-based and running off of our servers. Let me know if that wasn't quite answering your question.
Okay, awesome, Aaron. That's yeah, you covered a lot. Do you still have anything to go through, or I mean, we covered a lot, so
yeah, we covered a lot. I think we kind of hit all the key points. No, I think that's about it. I think we've covered enough that everyone should have a general idea of what it can and can't do. And of course, happy to answer any other questions that you guys have.
Okay, I have a question on and this is probably a tough one, because like most people that I believe are watching aren't using Augmenta yet. That's why they're here. They want to learn about it and so on. And we have had Endra on the show a few months ago, and now we heard about, like, everybody heard about Consigli, you know, but they got about out. Okay, sure. So you can't even access it anymore, probably. I mean, at this point.
Yeah.
And so how do you handle this question of like what app to choose if you're interested in getting all of this? Like, I mean, MEP is everybody's dream, right? The whole MEP.
Yeah.
But right now, you're doing electrical and there's doing fire, but they're moving to electrical. So how do you approach this question of competition? Why should somebody go with you and not with your competitors?
It comes down to what level of detail and certainty you are working at. We are the only system that outputs designs that contractors are actually using to build. And that is the difference. So I love what Endra is doing. And if you look at their website, it says for engineers. We are building this for contractors, and that is the fundamental difference. So everyone on this call who works on the trade side knows that the output from an engineering process is a design intent, and it always gets reworked to make it constructible. Especially on the electrical side, you're getting high-level 2D drawings, you're getting some roughly modeled in feeder conduit that has no details considered. Every electrical contractor, I've been talking to them for years, I've never met a single one that's using that output and actually building off of that. Like all of it gets thrown out and they're all remodeling it themselves. So we are working backwards by building systems that output actually constructible, actually coordinated designs that follow the code and constructability rules that you can actually execute on. And that is a very, very hard problem. And really our unique angle is that we're building these tools that embody the experience of a foreman from every one of those trades. Our electrical tool builds systems that output designs that a foreman would sign off on. Same for mechanical, same for plumbing. I know that the other tools do not do that. And the thing is that there are real problems to solve. There's a lot of opportunity on the engineering side. I think that even without that level of detail, you can still provide a lot of useful information to an engineer, and maybe you don't quite need that level of detail for them to do their work. But fundamentally, what we're trying to do is we want to shave months off of construction projects. And the risk and the delay and all the waste comes during construction. It comes during, well, pre-construction and construction. That's what we're tackling. So to summarize, I would say that for a contractor, I love what those other tools are doing, but they're not contractor tools. Those are engineer tools. They're simply just not going to output designs that are any better than what you got before, and are just not going to be something that produces a useful output for you. We will do that, and that's our focus. For folks who are more on the engineering side, ultimately what we're doing is we're taking the expertise of, again, those foremen from the different trades, and we're moving that upstream. So we already work with engineers who are using our output because it gets them actual coordinated output that they can give to their trade partners and have high confidence that their trade partner will build it that way. And I think that's really, really unique. And that's sort of where we've decided to focus. And the reality of that is that this is a very hard problem. It's much harder to solve that problem and to get that level of accuracy in 3D than it is to, for example, work in a 2D context, which is generally where a lot of those tools operate, or in a simplified 3D context where there's really not that much you actually have to coordinate around, and the output is, it's okay if it's approximate. Those are fundamentally different problems. They're both very valuable to solve, but they're for different people in different stages of the process. So hopefully that sort of gives you some, that's sort of like how we would sort of philosophically separate ourselves. And practically it's that, if you want to build, then we're the ones to work with.
So, I mean, focusing on contractors, I mean, I understand it's a turnkey contractor, then it's like everything's going on within that sphere. But if it's a contractor that gets hired later after all the design has started and people are, do you sometimes maybe experience that Augmenta is getting implemented too late in the process?
Not for electrical, because with electrical, the electrical engineers generally don't model a whole lot at all, very little. And the reason they don't do that is that generally the routing of an electrical system does not affect the performance of that system, whereas it does for mechanical and plumbing. So that's an important difference. And I think that even for us, as we move into mechanical and plumbing, our product and our target user may be different as a result of that. It's going to be more engineer focused because that's really where the value is. So fundamentally, when it comes to the actual process of figuring out how am I actually going to build a particular system, in electrical falls heavily on the contractor, whereas it's more distributed in mechanical and plumbing, I would say. So in practice, I wouldn't say so. Every electrical contractor, even on the most complex projects, they're starting with a model that has nothing in it. Like they do not have a modeled conduit that they're using, so they are implementing it at the right time. Again, when we work with our customers who are engineers, I think that they're using it the right way. They're using it to inform those decisions, really decide where things need to go. And fundamentally, if you're looking to save significant amount of money on your construction projects, it's really going to be found in those early stage design decisions. So if you can use something like this to bring insight into that, as in literally just understand what's it going to cost if I do X or Y, if I put this electrical room here or lay it out this way or that way, that's really the right place to use this. So I would say that philosophically, yes, this should be used as early as it can be in the construction process. But practically, we've never actually run into a situation where a user has been sort of too constrained using this, because in practice, there's very little for them to start with.
All right, we have a couple of more questions, but before we get to that, I want to just clarify something about Revit and so on. So, I mean, this is working within Revit, as you've shown. Are there any other tools that you are planning to open within? I mean, not that it would make strategic sense, so to speak, because Revit is king after all. But I mean, you can still cover more example, like you can work maybe with Speckle, you can do your work with IFC. How does it all work when it comes to like platforms?
Yeah. So our strategy has always been to be really agnostic. Right now we work with Revit because of the obvious reason, right? Everyone works with Revit, at least here in North America. Like I mentioned at the start, there's not a whole lot of business logic in these buttons up here, right? Everything is in our system. We've built our own geometry kernel. Our data model is not based whatsoever on Revit, so we could integrate into any system. We could integrate into other CAD systems when we move to other markets. And in that sense, that solves a lot of problems for us, because everyone integrates into Revit here. So as long as we integrate into Revit and we push back out in a very clean Revit format that doesn't impose, a particular structure to the data, then out of the box, we sort of work really well with everybody. IFC, if you can open it up in Revit, it will work with ACP. So again, it doesn't need to be a native Revit file. We read IFC just fine.
What about Revit families? I remember, because you don't know, but I worked for Sweco for 3 years.
Yeah.
And one of a few months I spent actually modeling electrical stuff. Yeah. I mean, so I remember some of it. And what I remember is that we had issues with some families that were 3D, some were just 2D, because we didn't have a need, like the deliverable was a drawing. So how does ACP work with Revit families? Do you need to have it all built out? Does it have its own thing that it can bring in? Does it work with what's already in the template?
We provide basic families for our bends and things like that, but that's very, very minimal. Otherwise, we need the site to be 3D, and you need to have modeled your electrical equipment. The good news is that, especially in the US, everyone has on the contractor side. So we never run into problems where there isn't really enough fidelity in the data. So we do have sort of very basic minimum requirements around the families, what's in them, as in they just need to be properly categorized. We need a panel name parameter. We need one electrical connector in there. That's it. So it's really quite light.
Okay.
So it's, yeah, very, very minimal requirements on that front.
All right. We have a couple of questions. Again, Marie and Tim, thank you for being so active.
You guys are awesome.
Yeah.
In Germany, contractors are such high demand. They don't care about working with superior software. They just do as they always did. How's your experiences of contractors in Canada and the US? Okay. It pains me to say this as a Canadian, but the Canadian experience feels similar to your German experience, whereas it's less so in the US. I would say that in the US, we found that there's a very high rate of BIM adoption. There's generally been a lot of interest in new software. I think that a big driver for that is the labor shortage. So even though the contractors are, yes, in high demand, there's a lot of projects, and the capacity to deliver on those projects is not matched by the size of the teams. Basically, everyone's trying to hire BIM modelers. No one can find them. They're very expensive. Everyone's outsourcing more and more. So there's a lot of internal pressure to try and sort of innovate. In Canada, I would say it feels a little bit quieter. We find that firms here are just not so far along in terms of BIM and technology adoption. Again, it does pain me to say that. So I imagine it's a similar dynamic in Germany, because you're right. Like, end of the day, I think that I mean, this is kind of going off track. I think that a big driver for BIM adoption in the US was the 2008 crisis. We were hit by that here, but not as much for, a multitude of reasons. And there was just less pressure, I think, for firms to sort of innovate or die the way there was in the US. And I think that was sort of in retrospect, a healthy push for that industry. So, yeah. Tim, can a smaller contractor use this, or does he need to be sophisticated with full in-house Revit capability? So I think that, okay, we definitely have small contractors using this. We have contractors as small as 1 or 2 modelers, but you do need a modeler, right? So I think that in practice, you can see that it does sort of require, well, it integrates in the Revit. There's some basic level of Revit knowledge required. You need to be working in 3D. You probably want to be working on projects where the other trades themselves are also coordinating, and you're actually getting something to coordinate around. Though we've had folks use this on projects where they would only coordinate around the engineer models for the other trades, and because they could get their stuff modeled so quickly, they could get it fabbed and get design sign off on that, so they can kind of beat the other trades, which they weren't able to do before. But I think fundamentally, there is sort of a baseline level of sophistication, which isn't very high, but you do need to have Revit in-house and know how to use it. If not, we do work with third parties, right? Third parties are very much a great user or sort of target user of something like this as well. So if you don't do that in-house, we can certainly work with your third party, and they can use this to get you that same benefit faster.
All right. Awesome. Thank you, Aaron. Listen, you're one of my guests that is so well-spoken and so detailed in his answers that I have basically an easy job today. So thank you so much for that. Listen, I have 3 more questions on my end, pretty much. So please, anybody in the audience that still wants something clarified, please ask. But I guess the first question is, how do people get started working with this? Okay, they saw the demo, they like what they've seen, they need to just get started testing it on a pilot project. What's the best way? They go to our website, reach out to you. How does it work?
Yeah, just go to our website, reach out to us. We've got a form on the site. We'll reach out to you. We can give you and your team a fuller demo, so folks who haven't seen it, can get caught up to speed. And then we have different options. If piloting is really important for you, we're happy to support you guys on a pilot. We like to work on live projects so that you can actually see the value, and we work very closely with you through that whole process to make sure you're supported. So we're extremely hands-on, especially during pilots. So you'll be in very good hands through that process.
Okay. I just, for folks on LinkedIn, I just posted the link. It's augmenta.ai, the link is. And I want to know, what is your financial runway? Like, is it an early stage thing, or like, are you comfortable right now growing, or like, how does it look like?
Yeah, so we've been around for a while now. We've been operating for about 5 years. Turns out it's a very hard problem to solve. We are VC backed. We're very solidly funded. We have customers. We have revenue. We're very comfortable into certainly late next year, and we're going into our Series A later this year.
Okay, exciting stuff ahead, man.
Yep.
Yeah. How big is the team?
We are a little bit over 50 people right now.
Oh, wow.
Yep.
Wow.
Yeah.
That's impressive. Wow,
Not
that's
kids
a
in a
big...
garage. No, it's a...
Sorry?
We're not kids in a garage.
No. Yeah. Maybe like probably like in 10 years they're gonna have like a Steve Jobs, Steve Wozniak story. Like it's just the two of us started at Autodesk. We didn't get what we wanted, so we needed to kick out on our own. So
That's right.
yeah. Okay. Roadmap. You mentioned, of course, you want to expand. But so let me ask you, when do you expect to expand? And is the first focus to nail this down first? I mean, it's already working well,
Yeah.
but there's always like, it can be faster, it can do this, it can do that.
Yep.
What's the focus right now for 2026 and beyond?
Sure. So we think about expansion in two dimensions, or a few dimensions. Let's start off with an electrical. Within electrical, right now we primarily focus on overhead conduit. So we sort of think about how do we help people save more and more time, and therefore let's target the activities that take the most time. The next step is underground. Underground takes a lot of time to model. We do sort of, like I mentioned before, have sort of partial support for that, but that's really big for us on the roadmap. That's absolutely something we're working on this year, because that would just add a ton of value. And some projects are only underground, or effectively only underground. So we think about how do we expand the range of activities that we help accelerate? So underground, but then there's also opportunities for us to move upstream. So branch planning, the grouping. So all those things that happen maybe at the very start of a project where you've just been awarded that project, and it is sort of that initial sort of planning. So kind of left and right, that's sort of how we think about it. How do we do more scope, and how do we start to move upstream to help people with that initial planning that sets the inputs, ultimately results in the inputs that you would feed into ACP. But in parallel to that, we're working on mechanical and plumbing this year. So if anyone on the call is interested in those domains or has a background in those domains, we are building out our network of design partners for those trades. So that means that we would work with you. You guys would be beta testing it, really co-designing that future workflow together. So that's the early stage we're going to be working on that through this year. So it's something that our design partners will have access to later this year, but not something we'll probably be releasing commercially quite yet. So really for us, our primary focus is electrical. It's still early days. Trust for us is really, really important in the industry. So we're going to be hyper-focused on not letting up the gas the slightest bit. There's a lot of work still to do, better solutions, more scope, more sort of helping with more and more activities, planning activities within electrical. So sort of at a high level, that's sort of how we think about it. I'd say mostly electrical, and then starting to do our initial strategic work around mechanical and plumbing.
Okay, Tim has a question. Will it interface with the Civil 3D model?
Not right now, but it's something that we would build out if we got a lot of demand for it.
Okay, so everybody who wants that demand, just like, I don't know, put thumbs up or reach out. Yes, awesome. Listen, my last question is basically like, you've been, I mean, for me, like, I guess the whole journey of like you starting with Autodesk, you're meeting Francesco there, you guys kick it out on your own because you realize, okay, we can have the freedom, we can build what we want. Maybe we have the contacts to even get the venture back. I don't know the whole story, of course, I'm just guessing here. But it's, I think that's a very interesting part. And now you're at 50 people, which is very impressive. And you're building the future, so to speak. So I think that's awesome. And you're actually one of the first tools that ended up on my list, AEC AI Hub, one of the first ones. So that's awesome. But in all of this, in the whole journey, what are you the proudest of?
I think that there's a couple of things. So there's two I want to highlight. I think one is that just very practically, we've made a lot of very real progress on really the hardest problem to solve in construction. there are probably other problems I'm not aware of in completely different domains within construction, but really doing 3D design is really, really hard at this level of detail. It turned out to be a lot harder than we thought it would be when we started this company. It's one of those things where you ask yourself, would I have done that if I knew how hard it would be? Don't ask me that. But we've now cracked it, right? We're now at a point where people are actually building real buildings with this. And that was really, really hard to do. We've gone through so much work, so much thinking as a team. I'm extremely proud of the team that we've built, just really brilliant people that it took to build this. And I think that's really notable. It really feels like what we're building here is infrastructure. It's not something that you can vibe code. It's not something you can just sort of build quickly or spin up a proof of concept around really quickly. It really takes years of work to get to this level. So I think that's something that, of course, we're going to be proud of, because that's sort of our jewel. The other side, though, is the relationships that we've built in construction. I think that we've been able to, build a really good reputation for just listening a lot. I think particularly because Francesco and I didn't come from construction, we knew that we didn't really know anything, and so we had to listen. So we didn't really come in with firm ideas or bulldoze anybody. We've got to where we are because we basically co-designed this thing with a number of design partners, and it's something that we'll make sure to not lose track of as we grow and move into those other industries, because it's really, I think, quite precious, and particularly in construction where these relationships matter, trust matters. These things take years to build. Buildings take years to build, so does great software, and you need that trust all the way through. So.
Awesome. I think that's an awesome answer, man. And you kind of reinstated the whole journey we're experiencing currently with NeoStack. So it's because it's like you started, you're like, yeah, this is gonna be easy. We're gonna build it in a few months, and it's always much harder than you expect.
Yep.
But then you need to appreciate the people who appreciate you first, right, and early, and so
that's right. Yeah.
Yeah. Awesome. Yeah. Good. I mean, good presentation. Awesome demo.
Thank you for having me. It's been great.
Yeah, you're quiet, but when asked, you go on, and it's like go in depth. It's a really you're really good at this. So this is awesome.
Thank you.
Yes. Do you have anything at the end you want to mention? You want to talk about, or?
Well, I guess I want to finish off with a reaction to your last statement, not about me, but about your experience with this. Is that I always thought that the very first customers who even worked with us were just as bold and admirable as any person building a startup. Like, it really takes that vision.
Yes.
I think to look at something and say, okay, if I squint my eyes, I know you're just showing me a deck, you're just showing me a demo. Yeah, I'll give this a try. And it's sort of interesting that I think, especially in construction, it's hard. It's hard to sort of build up momentum up in this industry. It always takes time. And so you really need those people. You really need those companies. And so this is just a general thank you to those folks who really started out on this with us years ago. We wouldn't be here without you. So thank you all if you happen to be on the call. And if not, we are looking for the same partners on mechanical and plumbing. It's a big journey, and we're looking to find some partners to do it with.
Yeah, we have 3 of those right now on for NeoStack, and it's just like the people there, like they're fighting for you within their firm, like and they are willing to pay you without you having a feasible product, even where it's always buggy, it's always like whatever, but they're there with you, they're giving feedback, they really believe in you as a person, and then the product as well. And of course you want to pay that off as time goes on, but it's an amazing part of this industry, finding these people and having these relationships. So
that's right.
Awesome, man. Listen, thank you. Hey, thank you not only for being on the show, but thank you for making the AC a better place. I think
we're doing our best.
Yeah. I think that people forget about this, about entrepreneurs. Like, we typically focus on, hey, what's the success you generated for yourself? But in the end of the day, it's like, if you weren't in this world, how worse off would it be? You understand? Like, you do something to change it for the better. And I think people sometimes forget that. So thank you for doing that for the industry.
Thank you.
Awesome. Listen, Aaron, you can stay in the back stage for a second if you want to chat after.
Sure.
I'm going to remove you now and just mention a few things for the guys on the call.
All right. Bye, everyone. Thank you, Stjepan, for having me. Hope to talk to you guys soon. Take care.
Awesome. Yes, great. Yes, guys, that was Aaron, and we hope to have him back probably when they build some mechanical or plumbing at some point. We'll see how fast that's going to happen. And for everybody still here, again, I want to mention the courses. You can join them because we're changing to something really exciting, a membership. So you can join them here, and you're going to be a part of that in the future. But I also want to mention who we're going to have next week on Wednesday. So Wednesday, same time, we're going to have Ichi. This is more for the architectural side, but they claim to have a lot of stuff within the app. So anything from code compliance to automations to combining your files, there. So I'm also learning. Also looking forward to learning more about that. And I'm just gonna send this link to you on StreamYard and YouTube. You can see it, and then you can sign up. If you're on LinkedIn, you can just go to my profile. The event is published, so you can just click attend there. Yeah, this is it from us this week. Thank you so much for the patience. Apologies again for those of you who joined the first one. So it was kind of rescheduled for today, but here we are. It was an awesome demo. And yeah, for any questions, go to augmenta.ai. And yeah, that's pretty much it, guys. Listen, God bless you all. Have a great day, evening. And yeah, see you next week then. Bye-bye.